Hi, 7th grade. Congrats on making it through topic 1, and welcome to your first lesson of topic 2. Today's lesson, we are connecting ratios, rates, and unit rates. By the end of the lesson, I want you to be able to say, I can use ratio concepts and reasoning to solve multi-step problems. So let's explain it. In a basketball contest, Elizabeth made 9 out of 25 free throw attempts. Alex made 8 out of 20 free throw attempts. Janie said that Elizabeth had a better free throw record because she made more free throws than Alex. Do you agree with Janie's reasoning? Explain. And decide who had the better free throw record. Justify your reasoning by using mathematical arguments. So pause the video, write something down for both A and B, and press play when you're ready to go over it. So, Janie's reasoning. I don't necessarily agree with it. No, because Elizabeth and Alex did not take the same amount of shots. So we can't necessarily compare them just yet. In order to really compare them, we have to have the number of shots they took to be the same. So decide who had a better free throw record, justify your reasoning using mathematical arguments. So what we can do is we can find the percentage that they made. Now, we can talk about part over whole, introduce that in this lesson. So if we want to talk about Elizabeth, her part was 9 over 25. If we do 9 divided by 25 in our calculator, that's going to give us 0.36. So she made 0.36 of her shots, which actually ends up being 36%. All right, if we do the same thing for Alex, he made 8 out of 20. If we do 8 divided by 20 in our calculator, that's going to give us 0.40. So, which is 40%. So who really did have the better shot? Alex did. So Alex had the better free throw because he made a higher percentage of shots. Focus on math practices. What mathematical model did you use to justify your reasoning? Are there other models you could use to represent the situation? So we used part over whole. We could have also gotten a common denominator and just compared the numerators. Okay, example number 1. Finding a unit rate. Nathan and Dan were both hired as lifeguards for the summer. They received their paycheck for the first week. Who earns more per hour? So it says that Dan works 9 hours and earns a total of $78.75. Nathan works 5 hours and earns a total of $46.25. Draw a model to show the quantities are related. So we are trying to figure out if Nathan makes $46.25 in 5 hours, how can we relate that to 1 hour? And same thing with Dan, if he makes $78.75 in 9 hours, how can we relate that to 1 hour? So we find what's called the unit rate. Unit rate is one of your vocab words. Okay? So we need to compare, and we need to think, how can we make 5 go to 1? Well, we can divide by 5. Whatever you do to the bottom, you do to the top. So 46.25 divided by 5 equals 9.25 over 1, meaning he makes $9.25 per hour. Now Dan, same thing. We want to take the 9 and turn it into a 1. So the way we do that is to divide by 9. Whatever you do to the bottom, you have to do to the top. So Dan makes $8.75 per hour, which means Nathan earns 50 cents more per hour. Try it. Jennifer is a lifeguard at the same pool. She earns $137.25 for 15 hours of lifeguarding. How much does Jennifer earn per hour? So in 15 hours, she makes $137.25. We are trying to get her unit rate. Whenever you see the words unit rate, write this down. Unit rate means the denominator is 1. So we are trying to get the denominator to be 1. So we have 137.25. We are trying to divide both sides by 15, both the top and the bottom. We find 15 because we need to know 15 divided by what equals 1. We'll divide by 15. So I get out my calculator and I do 137.25 divided by 15 to give me 9.15. So that means she makes $9.15 per hour. What do you notice about the models used to find how much each lifeguard earns per hour? Well, the models always go from the number of hours to 1 hour. And both of the numerators are money, and the denominators are hours. So what that's saying is that the money is on top, and the hours is on bottom. So always make sure that's lined up. Example number 2. Brian agrees to watch his neighbor's dog for 7 days. His neighbor provided a 128-ounce bag of dog food. Does Brian have enough food to feed all the dogs all 7 days? Use unit rates to find out how much each dog eats in 7 days. So first we have Buster here, and he eats 20.5 ounces in 2 days. But that doesn't tell me how much he needs for 7 days. So what we have to do first is take this and divide it by 2 to get to the unit rate. Remember, unit rate means the denominator is 1. So to get from 2 to 1, you divide by 2. Whatever you do to the bottom, you do to the top. Now, our goal is to find out how much he eats in 7 days. So to go from 1 to 7, you're going to multiply by 7. So whatever you do to the bottom, you do to the top. To move from one ratio to another, you're always either dividing or multiplying. Never ever add or subtract. So now Roxy, same thing. She eats 22.5 in 3 days, but that doesn't help us find how much she eats in 7 days. We have to do 2 steps. First, we have to find her unit rate, which gives us a denominator of 1. So to go from 3 to 1, they divide by 3. Whatever you do to the bottom, you do to the top. And now we want to get to 7. So again, we're going to multiply by 7. So Buster eats 71.75 ounces. Roxy eats 52.5 ounces. To find how much total we need, we're going to add them together. So the total amount of food that both dogs need is 124.25 ounces, which is less than 128. So Brian has enough dog food. Example 3. Suppose that each jump covers the same distance. How many jumps does it take each animal to cover the same distance? So it says the rabbit takes 3 jumps and makes it 8 meters. So this is what they're showing us in the picture. The kangaroo rat takes 5 jumps and makes it 12 meters. We are trying to figure out equivalent ratios. So equivalent ratios means that their denominators are the same. So equivalent ratios, denominators are the same. So here our jumps are our numerators and our meters are our denominators. So they skipped from 8 to 24 by multiplying by 3. Here they went from 12 to 24 by multiplying by 2. This is just like finding a common denominator. Whatever you do to one side, you have to do to the other. So a rabbit will go the same distance as a kangaroo rat. The rabbit goes there in 9 jumps, the kangaroo goes in 10. Try it. A kitchen sink faucet streams 0.5 gallons of water in 10 seconds. A bathroom sink faucet streams 0.75 gallons in 18 seconds. Which faucet will fill a 3-gallon container faster? Well, let's find the unit rate. So we have 0.5 gallons in 10 seconds. We want to find the unit rate, so I know I want it to be 1. So I'm dividing by 10. So I'm going to divide this by 10. 0.5 divided by 10 is 0.05. So in 1 second, the kitchen sink fills up 0.05 gallons. Let's do the sink faucet. Streams at 0.75 in 18 seconds. Well, we want to find the unit rate. Unit rate has a denominator of 1. So we need to divide by 18. Divide by 18. So I'm going to get my calculator. 0.75 divided by 18 gives me 0.42. I rounded that. So in 1 second, oh, I did that wrong, sorry. Hopefully someone caught me. 0.042. So in 1 second, the kitchen sink fills up 0.05. In 1 second, the sink faucet fills up 0.042. Which one fills faster? The kitchen. Okay. Great job, 7th grade. Let's all say it with me. I can use ratio concepts and reasoning to solve multi-step problems. Have a great day.